hope you're well and welcome to this live embedded conference session. Today I'm going to talk about software update and especially how we can make a basic support for a new platform. So for this session we will use a Microchip ATSAMA5D27 evaluation kit, which is a very nice platform for industrial application. So you can see the board. But first let's talk about me. So I am Pierre-Jean Texier, I am 30 years old. I work at Lafont Technology as an embedded Linux engineer, where my job is to develop and maintain the operating systems that we have on our payment terminal for fuel dispenser. Obviously, we use a well-known build system, the Yocto project. Also, you can find on the right a screenshot of our graphical application that we have on our new payment terminal. I am also a free software enthusiast and for sure an open source contributor. So I try to help the community as much as possible, even with the two children at home. So for instance, I did some contributions to Buildroot, OpenEmbedded, U-Boot and many other open source projects. So in introduction about what this talk will be covering, we'll find in first the motivation and why I have decided to present software update. Then I will introduce some concept for the update process, and I will present software update project itself, and I will show some key features of the project. So after that we will try to generate a clean setup for this session. To do this we will use the CAS project, which is a really nice project. Then the practical session mean a terminal session. In fact, this is where we'll try to port software update to the Microchip evaluation kit. So once this step will be fine, we will flash the disk image, and we'll do some test about software update, and we will try to do some update on the device, and then I will send all the patch upstream, so to the meta-swupdate-boards. Okay, let's first talk about my motivations about this talk. In fact, why I decided to talk about software update. For sure, during last 3 years, I've seen a lot of people on the mailing list, the software update mailing list, about how integrate software update onto the board. So this is why I think it is a good idea to help people to integrate software update by giving more example, especially with the Yocto project. So today into the meta-swupdate-boards there are only 3 boards supported. So we have the Raspberry Pi, the WAN board and the BeagleBone evaluation board. So I think the Microchip is a great nice addition. So also adding new platform is part of the roadmap as stated by Stefano in the documentation. You can see here a screenshot about the official documentation, and for sure it is nice to contribute to software update as well, in fact. So now let's start about software update process and software update project itself. Okay, so there are some key features on embedded environment. In fact, embedded has some differences compared to like PC, desktop or server side. So the first point is accessibility. In fact, nowadays we have a lot of connected devices. Usually we have sometimes no physical access to your devices, or it is very hard to get your devices, or at least it is very costly to get a physical access. So that is a limitation that you have to keep in mind when you have to deploy a new device in field. In fact, so second point is about the availability. So it is not usually easy to take control to your devices, so especially when this one is supposed to work with no downtime. In fact, so for instance, on gas station, it is not possible to say at maintainers that we will close his business for software update, so we have to take care about it during the conception. So the first point is the third point is a power supply. Sometimes your devices are deployed in complicated areas, so maybe this one is exposed of some power failure, and maybe you have to use a generator to ensure a normal function mode. So you have to handle this part during the conception of your device. Another point is about the connectivity. Sometimes, in fact, your devices are not connected directly to internet, but with a limited connectivity. So unreliable connectivity can appear, in fact. So the last point is about long lifespan, which is pretty long on embedded, sometimes more than 10 years. That is not the case compared to consumer products. I mean PC or smartphone. At least we hope that when we buy a new car with software inside. So this is why the conception is very important also from the hardware point of view. Indeed, we need to ensure that all the components, microprocessor point of view, will not discontinue during its life cycle. So choose the right components and keep in mind that the price, it is not always the key factor when we have to design a product for industrial application. So now let's start, let's speak about why we need an update. I think obvious, but it is just a quick reminder of some recommendations. So first, we need to fix issues. Yes, we don't write perfect software, and it is normal. So once devices are deployed and filled, we need an easy way to update software, so locally or remotely. It depends on what you have to handle this part. Second point is also important, since you have to deploy add features on your devices when this one are installed, and this is for sure the case nowadays when time to market is often a requirement for the project. So you can deploy your devices with some basic features and add features later with software updates. The last point is about security updates. I think it is obvious for everywhere. You can check the CVE database to check if some vulnerabilities are inside your device. What we need to update here, an image about all the components that you can find on embedded. So the bootloader, the kernel, the device tree, the root file system, all the runtime data, for instance, all the certificates, all the customer configuration, third-part firmware, for instance, FPGA, STM32, and so on. About update strategies, there are some kind of strategies, but at least two that we are able to find on some devices. The update scheme strategy is, I think, the first decision you should do when you're planning to build something, that it is updatable with an updater agent. In fact, you have to choose which is the best strategy you want to use. So the first strategy, often called recovery operating system or asymmetric update scheme, where the goal is to provide an easy way to update the system without the need to have a lot of gigabyte storage. In fact, the upgrade consists of a minimal kernel and small root file system with just the updater agent and its library. So the system must be put in a recovery mode from user space area. So to do this, you have to update the flag to the bootloader. Once this flag is there, the bootloader goes to the recovery operating system, so which is just an initram file system. So the updater agent is able to upgrade the whole partition since the recovery is in RAM, in fact. So this is something what Android used before, in fact. And this scheme is fail-safe, since that if an update fails, you always have the ability to go back to the recovery operating system and you need to try again. But the main issue regarding this strategy is the downtime, because while you're flashing your updates, the device is unusable. So this is a problem if an update fails several times in a row. So this is why we are able to find another approach. The second approach removes the recovery operating system, and you have now two root file systems that are identical to each other. So the concept is to have an active root file system and another one called inactive operating system. This scheme is also called seamless update, because one of the key feature of this is that you can update the inactive root file system while the active operating system is running. So no downtime. Just need to reboot to switch to the new active partition. So this is very nice feature. So on the new active partition is started, the old partition, the old active one becomes the inactive partition. So also the key benefit is that this scenario is very safe, in fact. So if an update fails, you just need to roll back to the old active operating system to retry an update, so no downtime. But for sure, downside with the approach is that you need to keep 2 copies of the root file system, which consumes more space in storage as having just 1 copy plus a recovery operating system. But not a big problem nowadays, because flash storage is less expensive than before, so it is easy to find a device with some gigabyte. Okay, now let's speak about software updates. I put some important information. I think you can reach easily the documentation. The project is maintained by Stefano Babik from Danks, very well documented, mostly written in C. The format used by software update is a simple CPIO archive, so at the end just a SWU file. Software update use a libconfig single file to describe the update package. So the file is named software description, where this file must be at the first position inside the CPIO archive. So now some key features. So software update is able to interact with some bootloader. Also, software update support both asymmetric and symmetric strategy. So you can add both strategy if you want. So I let you read all the key features. How to update on your devices. Software update support both local and remote software. So on local software update, you just need to pass as an argument the update package, and for the remote you are able to download from an FTP, SFTP, or from the beginning there is an internal web server, so you just have to drop your update package on this web interface. And also you are able to integrate the Octbit backend with software updates if you want to use this one for fleet device management. So okay, now let's discuss about the setup for this session. So we will use CAS, a tool developed by Siemens and maintained by Jan Kiskla. The tool supports Docker and Podman through CAS container scripts, and it tends to be a reference since there are more and more users nowadays. So this project uses YAML or JSON file to describe all the layers that we need to fetch for a specific project. So also there are some configuration inside the file, especially if we need to set up some variables that we need to go into the local.conf or babylayers.conf file. So I let you read all the features in the slide. Regarding our needs, we need first POKI. POKI is a reference distribution of the Yocto project. Then we need the meta-atmel for the support of the microchip processor. Also the meta embedded if we need to add some packages on the device. And then we need to add the software update support, so we need to add a meta software update and meta software update board. So we need a way to organize them properly. So what I proposed is to split them in several files. So 4 files in fact. So the first file is named class layers, where this file is used to describe and fetch the meta HTML and the meta open embedded. You can find on the screen. Then I created a CAS Pocky file where I use the specific branch repo of Pocky plus the revision. I've defined the distro as Pocky. Distro variable is a distro variable that you are able to find on the local.conf file. We include statically the CAS layer file. So, and then I've put some variables that needs to use. For instance, some systemd variables that goes to the local.conf file. I also use some variables to reduce this space. Okay. The third file is about the machine itself. So machine here is the machine variable that you are able to find on the local.conf file. And the last file is about software update. So this file includes the machine file and both meta software update and meta software boards that we need to fetch to include the software update support. Also, we need to add some variables to define the specific version, the preferred version in fact. So I use a Git version, and I added some image fs type. So we need to add an xcat file plus a weak image for disk image, and I added some packages that we need on the target. So we'll discuss this just after. Okay, now our setup looks okay, so we just need to install CAS itself. So to do this, we will download the CAS container script directly from the official GitHub repository as shown on the slide. If it is okay on your side, you just need to run the following command. So CAS container build, first file is CAS Pocky with the command line inclusion with the software update support. Okay, so when you run this command, Bitbake try to generate an image. So to recap these steps, I put on ASCII-Lemma a terminal session that shown all the steps, so no worries about that. So after that, we'll have all the layers, but with some issues, in fact, with Bitbake. But it is normal since software update tries to do some things with our board, so something is missing in fact on our side. So we'll fix it now. CAS, okay, but not the only one. Okay, so there are some tools to fetch layer in fact. So for instance, git submodule, repo, combo layer, or the last one is Yocto Cooker, a fairly recent project developed and maintained by Christophe Blaes and Patrick Boucher. So never tested, but looks like promising in fact. So okay, so now I'm going to show you how to integrate software update onto the device. So first, let's recap all the things that we have to need before. So the first thing that we have to do is the creation of the partition shames for the SD card. So we will create a new kickstart file, and then as previously defined, we need to use the WKS file. So this is a partition layout of the SD card, in fact. So after that, we will add a new machine in meta-swupdate-boards, like the Raspberry Pi, in fact. So first, we need to define the software description. So what kind of image we need to generate, and then we will create the software update configuration file. So in fact, this is just the software updates runtime configuration file, and then we will add a dev config file for the configuration of software update itself. It's just for the compile time, in fact. So if you need a specific option, you need to run bitbake menu config software update, and then update and add your option and generate the dev config. So that's it. After that, we will need to handle the behavior of software update at runtime. So where the update goes to, and also the web server configuration, Ocbit configuration, and so on. So, and at the end, we need the U-Boot integration. So we need a way to pass a variable to the U-Boot environment itself. So we need to do some tricks inside the meta software updates boards regarding the U-Boot. Okay, so let's go. So as I said previously, the first thing that we need to do is about the partition layout. So here is a file that describes the layout of the SD card. So we are able to find the first partition for boot artifacts plus the U-Boot environment. So the U-Boot environment is just a file, in fact. Okay, and then both root FSA and root FSB. So now once the image will be on our side, we'll have image with a dual copy approach. Okay, the second configuration that we have to do is about the software description. So here is the description of the image that software update generates. So this is software collection, in fact. So at the top level, the software, and then the version, then the machine. So in our case, the ATSAMA5D27. If the OS, for instance, is considered stable or not, we can add a lot of image type. And then, since we have a dual copy approach, we need to add a specific configuration for the copy 1 and copy 2. So inside the copy 1, we are able to see the images. Images is just a plugin to install a specific image onto the device. In this case, a core full CM_line.x4 .gz for row type. In fact, the SHA is updated by a specific class inside the meta software update, and we need to define the device, where the device is, in this case /dev/mmc blk0p2. Also, we need a way to update U-Boot at the end of the update process. So software update are able to handle this part. So let's create a root part variable. And in this case, the value is 2, and the same for the copy 2. And then we need a way to control at runtime the behavior or software update. So we need to detect where the update goes to. So a quick trick is to check where the root file system is mounted, and just update the selection. So selection, in fact, is just an argument for software update to inform where to install the image. So if the device, if the active root file system is mounted as partition 2, we need to update copy 2, and in this case copy 2 refer to the third partition. Okay, also we need to control the behavior of Hawkbit. So with the SWUpdate module, so it's just a trick. This is the same that we have with the Raspberry Pi and other boards, in fact. And at the end, we need to pass a software update argument with a hardware board plus the revision, the selection, and the configuration file. So the configuration file is defined here. So it is a generic file. In fact, we are able to pass all the arguments from the command line too. In fact, but to be consistent, I use the same file for as the Raspberry Pi. So we need to generate some identify. For instance, board equal ATSAMA5D27-SOM1 and so on. We can control the web server behavior, where the web server is installed, in fact, and some configuration for SWUpdate. SWUpdate is just for Hawkbit, and also we're able to control the downloader plugin. We're able to control if we want a syslog output or not, if we have an authentication process with a public key authentication. In this case, not. It's just a demo board, so no need to add security for that. Okay, and the dev config is quite the same of the Raspberry Pi. I just updated this one since there is some modification on the last version, so I have to do the same for the Raspberry Pi. So now we have some new U-Boot, new config variables, in fact. Okay, and now we need a way to control the U-Boot process. Okay, since meta-HTML uses a plain text file to describe the U-Boot environment and generates the U-Boot environment itself at compile time, we need a way to append this file. So I have added some variables, so but in fact just one, the 8091 set root part variable. This one allows to append the root part variable to boot args, in fact. So this one is executed at runtime just before setting the correct boot args, as you can see here. So now U-Boot is able to switch the correct root file system depending on the setting of the root part variable. Okay, so now that we have all the components for our platform, means SWUpdate is correctly configured, we just need to generate an image, in fact. So let's try to generate that. So to do that, you just need to run the following command, and we'll be able to generate our image. Okay, so let's try. Okay, so and at the end we'll have the correct images that we will be able to flash. Okay, now it seems we are able to use all the materials generated by Bitbex. So now we are able to use a weak image and the update image here. So we just need to update first the device and after update the device with the update package. So let's try this one. So the first thing that we have to do is to flash the SD card with the disk image. In my case, I don't use DD because it can be dangerous in case of wrong use. So I prefer to use BMap tool, which is a very nice and common tool. So if you want to show this command in action, you just need to reach the ASCII terminal session at the following link. To deploy the update artifact, I use tbot. Tbot is a testing infrastructure, in fact, developed by Harald Seller from Danks. This tool is able to interact directly from the devices. So if you want more information, you can reach the documentation, and this one is useful for CI usage, in fact. Okay, so now we will try to update the device with tbot. So on the left terminal we have tbot lab, and on the right terminal we have a terminal session connected to the device. So as you can see, we are currently running on the first partition. So let's go. Just before, we need to check the progression and we need to start tbot. Okay. Okay. So for tbot, the upgrade is okay. Now the board is rebooting, and you can check now that we are currently running from copy 2. Okay, so as promised, it's time to send patch upstream. So let's go. First we will check that all the changes are here. So okay, the environment is here. U-Boot is here. Okay, seems correct. So now just need to generate patch. So okay, so now inside output we will have, yes, all the patches. So now we just need to send email. And now if we try to reach the patchwork interface, well, in fact this is a place where patches are received. So now we are able to see our patches. Okay, so now patches are sent upstream. It's time to conclude. So what can I say is that SWUpdate is a great framework that deserved more example regarding board integration. So if you have any board integration on your side, so do not hesitate, I think, to send this to Upstream SWUpdate. Okay, so that's it for me, and thanks again for attending this talk. And if you have any question, feel free to ping me on the chat.